So thanks so much, everybody, for coming around today on our session about shared mobile UIs with Compose Multiplatform. We have a fun little journey ahead of us. We're going to see a bunch of different things, how Compose Multiplatform equips you as modern Android developers with new superpowers, with shared mobile user interfaces that run on both Android and iOS, and even beyond that. I have a bunch of things I want to get through today. We'll see where Compose Multiplatform fits in the overall story of Kotlin Multiplatform and code sharing there. We'll see how established APIs actually make it a lot easier to get started with Compose Multiplatform than you might think. And in the process, we're going to learn a whole bunch about Compose on iOS, including a bunch of live demos. I'm going to do a little bit of a speed run of trying to migrate an app from Android to iOS. And we'll see how that goes, so fingers crossed already. Loads of things, 40 minutes, we're going to dive right into that. I don't want to be rude, though, so let me introduce myself. My name is Sebastian. I'm one of the developer advocates at JetBrains for Kotlin and for Compose Multiplatform. You may have seen my face before on our Kotlin YouTube channel, or may have heard my voice on the Talking Kotlin podcast, and may have read some blog posts and some other stuff. Side note, I'm also a huge Back to the Future fan. Believe it or not, this will become relevant later in the presentation, so remember this fact. OK, first of all, let's get everyone up to speed and onto the same level about the Kotlin multi-platform story in general. I'm going to visualize this using the mobile use case, because that's hopefully one that resonates with all of you. But because Kotlin multi-platform actually goes quite beyond that and has a diverse set of targets, the whole story actually generalizes. But let's say you're working on a product and you need to ship an Android app and you also need to ship an iOS app. With Compose Multiplatform, you have an option about sharing all the kinds of code that is supposed to behave the same on different targets and essentially eliminate unnecessary duplication. So the idea is that you share everything that's supposed to have the same behavior, but also not give up access to all the platform-specific capabilities and the things that the individual devices can do. So by writing the business logic, for example, in common Kotlin code that is shared, you can then compile that down to your different targets and save yourself the effort of kind of duplicating the implementations and keeping those in sync. And then because we have things like expect and actual declarations, which is built into Kotlin Multiplatform, you can still access everything that's underlying there. So this is the classic case that has been validated already by tons of different projects, and that case is also not going away. But we realized that there was kind of one piece missing in this story, which is for when you don't want to build and maintain two different native UIs for your target platform separately, right? Because the classic case, it suggests, well, you can do Swift UI on iOS, and then you do Jetpack Compose on Android. But you might find yourself in a situation where you maybe don't have enough people, where you maybe don't have enough time, or maybe because you just want to get your app out of the door and into the hands of as many people as soon as possible. And that's exactly the thing that Compose Multiplatform enables. It allows you to implement your user interface once and then use it for all the platforms you target. In this scenario, it's iOS and Android, but actually you can throw in a couple of other platforms as well. Because it is worth pointing out that Compose Multiplatform is the overall initiative that we have at JetBrains for bringing cross-platform UI development to the Kotlin ecosystem. And while that includes mobile, it also goes way beyond that. We target Android and iOS, which is currently in alpha, but we also target desktop, for example, which we already stabilized, and we are already running in production on over 1 million Windows, macOS, and Linux machines. We're also working on Compose for Web, which works via Kotlin for WebAssembly, which is currently experimental, but was actually already featured at this year's Google I/O from the Chrome team as one of the case studies for the amazing future of what you can do with WebAssembly. But today we're going to zero in on the mobile case, just so that our scope doesn't entirely explode. So we're going to talk about sharing iOS and Android. We've all seen Compose apps on Android before a couple of times, I'm sure. So the focus of today is going to be on kind of the Android part of this sharing story. And that is something that we announced as alpha at this year's KotlinConf less than 3 months ago. So the main pitch or the magic value that Compose Multiplatform brings to you as Android developers is that you won't have to start from zero when you want to build cross-platform UIs. Because Compose Multiplatform actually allows you to build user interfaces using APIs that you already might know. We'll explore this claim in a little bit more depth later, but just to summarize, whether you're already an established Compose dev or you're currently learning it, the stuff that you're learning also applies to Compose Multiplatform. Except for a very small sliver, most of the APIs between Jetpack Compose and Compose Multiplatform are exactly the same. Which means with Compose Multiplatform, if you've written an Android user interface using Jetpack Compose, you can now also just write iOS apps as well. So I always have a bit of an easier time remembering things when they're attached to something visual. Bonus points if it contains like cute cat imagery. So I say we have a quick look at a Compose Multiplatform application, and then we'll just kind of explore and see how that one was built. So first of all, let me pull up my Android Studio here, and here we can see the app running on Android, and then if I open up QuickTime, you can see that on my iPhone here, I can open up the same app. So this app is my Memories app. It's the place where nowadays I store all the most important events of my life. You know, like the kind of time when I was still in like when I was still studying software engineering, and I solved a task really, really quickly, and I got this donut for it from the professor. Very tasty, but you know, it didn't last, but this memory will last forever. Or the time when we actually went on stage together with my colleague Nikita, and we announced Compose Multiplatform at KotlinConf earlier this year, again, with quite a big crowd right here. But of course, it also includes events like when I first met the cat that is owned by my friend, and she's a super, super cute cat. If you read the text, you'll actually find out that her favorite meal is soup. So what we did was, when we located this memory, we made sure that we actually put her right in the city center where one of our most famous soup restaurants is. But we can kind of take a closer look here at this Apple map and kind of see where exactly she would be placed. Now, of course, presenting here at DroidCon is also one of those core memories that I would like to savor. So why don't we take a picture together and also make a memory here? If you would not like to be in the picture, you can use the conference-provided sensor bar, or maybe like slouch, do one of those things. Yeah, and we're just going to do that very quickly. I'm going to try not to rip out this cable. All right, thank you, everybody. Thank you for your participation. Clap for yourself. Wonderful, great. So that's just a tiny little app. And needless to say, the same app that I have running here on my phone, I could also run on my Android device, and I could do the exact same thing. Just in this case, I have a Google map, which I didn't set up an API key. That's on me. I'm sure I'm not the first person who forgot that part. All right, cool. So we have seen a small little app that's built in Compose Multiplatform. But so far, we've kind of only seen it just kind of from the outside. So I think it's time we kind of dissect it a little bit and kind of break it down. So obviously, this shows off a couple of the parts that are already working. I can actually tell you that I wrote a part of this app together with the Compose Multiplatform team. And the thing that I liked the best about it was just how quickly I was able to get started. I don't have like iOS or Swift UI development experience, but I did have some Jetpack Compose experience. And it was honestly almost frightening how quickly I could get started. Because if we look at this kind of app and we look at this image up there, that's just the image component that you might already know from Jetpack Compose. And I'm not saying it's a re-implementation or it's an API that kind of looks like it. No, it's literally the Android X Compose Foundation image. It's precisely the same one. If we look down here, this one is implemented using a lazy vertical grid. Again, it's just the same component that's built into the Compose foundations. With the button down there that I used to trigger taking a new picture, that one we went a little bit fancy. We could have just used a built-in button component, but we wanted to be a bit extra, so we used a box with a modifier, with size, clipping shape, and we made it clickable. But again, these are APIs that you kind of already know, right? These modifiers, if you've written Jetpack Compose, you can read this code. There's nothing special about this. And in fact, this stretches to most of the topics when it comes to shared UI with Compose Multiplatform. Animations behave the same as the DSL, like they use the same DSL as an Android. The little parallax effect that you have when you scroll, you can just build that on top of the animation and Compose APIs, transitions, and so on. So the main takeaway really here is that when you're building shared UIs with Compose Multiplatform, you're already building on the same blocks that you would if you were just developing on Android, which again means it's really quick to get started. Now, obviously, it's also worth pointing out again, these aren't like two separate apps where I copy-pasted things. This is all a shared code base, so if I would make a change at one part of the app, then both of my Android and iOS apps would update as well. We also saw that there were a couple of more complex widgets that actually came from the platform, like the camera feed that we showed, or maps, or maybe web views, those kind of things. Those are obviously target-specific, but because we build on top of Kotlin Multiplatform, that guarantees you this kind of interoperability with the underlying system, we can still do things like provide a location visualizer implementation that works specifically for iOS, and that invokes the MK map view from MapKit and just embeds that in your composition. Or we can add, for example, from AV Foundation, the video feed. So that's one way of being able to do interoperability. We can also do it the other way. If we have an existing SwiftUI application, we can actually choose to render only specific screens with Compose Multiplatform. So we can kind of take a look at this example here. While the top bar and the bottom bar, so the navigation and the tab bar, that's managed by SwiftUI, the actual Compose view that's sitting in the middle, the chat view, that's all rendered using Compose Multiplatform. And still, even with this, we can have UI elements like the SwiftUI text field floating on top of it. The on-screen keyboard works just as you would expect it, and that works quite well. So, and this obviously gives you the ability to kind of provide some kind of gradual adoption, right? You can go step by step if you already have an existing code base and you want to switch out specific parts of your app with Compose Multiplatform. All right. This is, of course, all very fancy, and of course, we showed off a wonderful demo of all the things that already work. But it is time to once again stress that Compose Multiplatform for iOS is currently in alpha, so there's a lot of things that are currently still work in progress. Because building a cross-platform UI framework isn't easy, and we obviously want to make sure that the experience is good wherever you run your apps. This starts from like very small things that might seem simple but are really important, like the way that you handle scroll physics or gestures. Because the moment you have an application that doesn't scroll like a native app, it just feels weird. But it extends also further to things like navigation principles or, for example, lifecycle management and resource management, as well as more complex interactions. So stuff like text selection that we're currently working on, input management, or pop-ups and dialogues. One of the things that we think is really, really important to support is solid accessibility integration, because we want to make sure that we both respect all the user choices as well as make your apps available to as many people as possible. That's things like text to voice, to zoom, to contrast preferences that the user set. I know that this is a lot of different points, but we do want to put proper thought into all of them because we want to make sure that it's the best experience we can deliver. One more topic that's, of course, very important is consistently providing absolute smooth frame rates, especially nowadays with high refresh rate displays on the higher end devices. That's something where the Compose and Kotlin multi-platform, the Kotlin native and Compose multi-platform teams are actually working together quite tightly. There's a lot of things going on under the hood here, but I would honestly say that I'm probably not the right person to talk to you about all of this. If you are interested, I would suggest that you take a look at the joint talk that I gave together with the Compose Multiplatform team lead Nikita, who is going to explain a bunch of the different topics about kind of what's going on under the hood. So if words like mark and sweep with stop the world are things that are exciting to you, or you want to know how we are building like our native garbage collector, then you can take a look there. It's available already online because it was held this year at KotlinConf. So obviously, now we go in the other direction again. While there are a lot of things that are still work in progress, the parts that already work actually fit together very, very well, which means there are already a lot of things you can build with Compose Multiplatform already. Before I go into the different kind of case studies that I've brought with me, I need to be clear here that from an official standpoint, Compose Multiplatform is in alpha, and we do not recommend production use of this technology at this point. But also, I am not your dad, so I can't stop you. We're, of course, super excited for everyone who takes the technology, tries it out in whatever context. And I've brought a couple of folks with me. If you were at Hadi's keynote, you probably saw a little bit of an overview, so I'm going to go through these a little bit quicker. It's important to note that we announced Compose Multiplatform for iOS at KotlinConf 2023. So obviously, our first case study comes from DroidCon New York City 2022. Remember how I said the whole Back to the Future time travel thing was going to become relevant? I guess that's it. I'm not really sure. It turns out that the Touch Lab folks actually already started building the DroidCon apps, even with a pre-alpha version of Compose Multiplatform for iOS. So if you were at DroidCon New York City 2022 and you had an iPhone with you and installed the official app, that was already running on Compose Multiplatform with shared UI. And even they wrote a very nice article about this, which kind of details everything. I pulled out one of the more flattering comments, which was the dev process went way better than anybody expected, which for a pre-alpha version, we take those as a win. That's definitely a win in our book. Talking to Kevin on Twitter, it also seems that going forward, all the DroidCon apps are going to be built with Compose Multiplatform as well. The current one is stuck in App Store review hell, not because it's a Compose Multiplatform app, but because it contains the abstract to my talk in one of the screenshots, and Apple really doesn't like the word Android. It's the only reason. Instabee is a logistics company that already from the very start kind of anticipated that they wanted to do some kind of sharing. So they built their whole application as essentially common Kotlin code without any platform-specific dependencies. And at this point, they're already delivering millions of parcels every month by equipping their drivers with Compose Multiplatform apps that manage the delivery. Because they already structured the app in kind of a unique way where they already kind of removed any platform-specific dependencies, they actually got their app working on iOS in just a couple of days, even though they had like over 50 screens, which is once again very exciting. Little time travel anecdote, the moment I heard about this case study was 5 minutes before I went to go and present Compose Multiplatform for the first time. So again, somehow people just keep finding our open source artifacts and keep throwing them into production. I'm very excited about it. I'm glad it works for them. And the last case study that I've brought with me is Velobank, which I think Hadi also briefly mentioned. I wanted to point them out again because they also once again serve as a reminder that while we do the mobile cases, Velobank actually also built a prototype of their app using Compose Multiplatform that runs on desktop, just on the regular JVM. Because they put abstractions in place in advance already, that kind of allowed them to switch out the underlying system quite easily to arrive on a prototype for their app in just a couple of days. Okay, these are obviously very impressive statements. There may be very big claims, so I figured it might be a little bit more interesting to actually put this to the test. And I figured we just take an official Compose sample, and we'll see how long it takes us to move it to Compose Multiplatform. So let's just see here. I'm just going to move this over here. Let me see. That text seems like you would be able to read it, so let me just kill this application here. And great, spoilers, thanks to the Android emulator. The application that we are going to be moving is the Rally app, which is a small Compose Code Lab from Google that I haven't touched before, which is just this nice little application that does like a little bit of finances. It has some animations. You can, of course, have a little bit of scrolling. You can navigate around, and that's kind of it. OK, so let me close the image viewer that we had beforehand. And this is the source code, promise, fingers crossed, the untouched source code of the Rally Code Lab. So the typical way that you start using Compose Multiplatform usually is to go to jb.gg/compose and scroll down a little bit and hopefully read a bit about the technology before you jump in. But we do have a couple of templates that are linked here, for example, the Compose Multiplatform mobile template. This one also comes with detailed setup instructions, so you know how to set up your system. Because we're targeting iOS, you will need a Mac to do this kind of stuff, but hopefully that shouldn't be too much of a barrier. However, there are also, because we actually also have a little bit of an ecosystem that surrounds Compose Multiplatform already, and that we'll talk about in just a second, there is also the Moco Compose Multiplatform template. And this one just adds a bunch of dependencies, which is going to make it a little bit quicker for me to do the migration. So I'll just be using this template. I've already checked it out. And if we open this one up in Android Studio, and switch to the project view, we'll see the typical structure of a Compose Multiplatform project with an Android app, an iOS app, and a shared module. So let me just head over into the shared module. By default, all the source code for our common UI, for example, or just generally our common logic, is stored in the common main source set. There's a bunch of examples here, so I'm just going to delete those for the time being. And all of the stuff that actually invokes these, we're also just going to get rid of. At this point, we should be left with an entirely blank application, which I can start from Android Studio once on the Android phone, and then we'll also start it on an iPhone. This is going to take a while because it's the first compilation, so we're just going to let that rattle on in the background, and we'll be convinced in a second that that will hopefully work correctly. OK. And now we can already start migrating. We'll start migrating very easily by starting with the resources. There's a couple of things like fonts or images in here. I haven't really taken too close of a look in it, but they also have, for example, localized strings, those kind of things. But we can start very simply without even trying to understand the structure of this, just copy-pasting this into the MR, which is the multi-platform resources folder, and we'll just add that one. At that point, we should be able to execute our, because the multi-platform resources are actually a compiler plugin, we will execute a Gradle task. Let me just look that one up for a second here. That's the generate MR. I really wish I had autocomplete. There it is. OK, first of all, thank you. Generate MR common main. So we'll let that one run real quickly. And in the meantime, we can convince ourselves that hopefully once the Android compilation is done, which we'll just give that another go, hopefully we'll see a blank screen. On iOS, we're already seeing the blank screen, so that's already great. And as Android compiles, we have an invalid resource directory name. OK, give me just 2 seconds here. And we'll start this one over. OK. So we'll just start this one from a blank project again, because I guess when I pre-checked this one out, got a little bit of a hiccup. Well, that's OK. So I'll just make this one Rally 3. And that's the wrong template. See, this is, I should have prayed to the live demo gods. That one's on me. I'll be honest with you. Didn't light enough incense this morning. So Rally 4, I guess. And we'll Then we'll just give this one another go. So from the general structure, going back, we'll let this import in the background, but because I'm on a little bit of a time crunch, we'll do a little bit of a thank you. We'll just get rid of all of these once more. We'll delete them anyway. We'll clear out our app. We'll go into the resources folder. Oh yeah, now I remember what was the issue. What was the issue? That was just me being silly. Fun. Okay, so we'll open up the original rally again. So here's the thing, right? There's some very slight differences, and this is exactly the kind of thing that I wanted to point out. You need to do a little bit of work. In this case, the difference is, unfortunately, that the multi-platform library calls this folder fonts instead of font, which, that's a... So that's maybe worth logging an issue with those folks. Yeah, and they also don't call their localized strings values, they call them base. Again, you can see how maybe that trips you up when a lot of things are going on. Okay, we'll do the generate MR common main again, and from here on out, I'm sure it'll be smooth sailing. Because now we can do, hopefully, what will be the slightly more impressive part for this demo. Because how do we migrate the rest of our code? Well, we grab the folder that or the directory that contains all of our source code, and we put it into our common main directory. Cool. So that's about 90% of the work done. That's already great. There's a couple of things obviously missing. Like, for example, if we go into the rally screen, we'll see that, oh, these icons are missing. Well, that's just a dependency thing, because these come from the extended set of material icons that are, of course, not included by default. So we'll just add a little bit of a dependency. Sorry, that's a compose dot, and then that's just material icons extended. And we'll sync again. And then hopefully, we'll already see the first couple of issues melt away. Great. So, and now we can essentially just go through and we'll take a look at some of these classes. These are pure Kotlin classes that aren't even related to any kind of underlying dependencies. So yeah, we don't even have to touch this one. In the accounts body, we'll notice a couple of broken imports, mainly because of string resources. And once again, there's a couple of small changes here we need to make. First of all, Android Studio is very helpful and already tells us, hey, why don't you use the MoCo, the multi-platform Kotlin resources instead? So we can just, if we actually take a look here at the import section, I'm just going to comment the two things out that are broken, and I'll just import these automatically. So once we have the string resource, then we have MR from the MoCo resources, and then once again, we have strings plural. This time I'm getting IDE support, so this one I'm not missing. Great. So we see that there's two things that we need to change across probably a lot of files, and that is that we need to move the Android X Compose string resource, and we need to replace this one with the common implementation of string resource. And we'll do that, and we'll just make sure that that only hits the right things. It does. So we'll replace all of these so we can remove the first comment. And we'll also see that instead of rally.r, what we actually need to do is we need to use the common MR as an implementation. So let me just make sure that I'm only replacing the correct ones. We'll replace these across all the files as well. And then the last thing, of course, was the string resource, which originally looked a little bit different. So originally it was just R from the Android class, and it was string dot. So we'll replace all of these, and OK, cool. So that should hopefully already get us a slight step further. Let's have a look in the builds body file. That one's good. OK, we don't need to change anything, even though those all use regular composables. Even though it uses the Android X implementation for composable, that's all good. The animations for the animated circle, they all work out of the box. I don't need to make any changes. Common UI, we have a broken import. Why is that? Because they use decimal format. Yeah, so at this point, we unfortunately have a little bit of a lack in our Kotlin in our Kotlin standard library. There's a bit of a long-standing issue for decimal formats. I have just brought myself a small little implementation that also does decimal format. in the same way. And of course, if you are a fan of Compose Multiplatform, I would encourage you to vote for the issue KT21644 for adding formatting for decimal numbers in our common standard library. For now, this will suffice, though. Of course, you could also use a third-party implementation for decimal formatting. Once again, the alert dialog serves as a reminder that we are alpha technology and not everything is supported yet. So the alert dialog currently doesn't work, but it's on the roadmap and will be released in a couple of days. Sorry, not in a couple of days, but in a while in one of the upcoming releases. Yeah, I just threw someone under the bus on the team there. For now, we can stub this one out. So we'll just have it do nothing to make sure that we don't actually have to change any of our code. We'll make sure that these are annotated as composables, just so that once the implementation is there, we can just remove this little snippet and it'll work. But hey, the file is green. That's already good. In the top bar, we are using the Java util locale. Instead, we can just defer that to the regular uppercase function that's in the Kotlin standard library here. We can do the same thing probably in the statement body. Nope, that one already works out of the box. Great. In the overview body, I think we're seeing something very similar. We see, first of all, that in common code, we're currently not supporting the preview annotation, but you can still do this if you are in the Android source set. So hopefully it won't be too much of a holdup, as well as the locale. So I'll just go in here. I'll remove this preview annotation, and I'll remove the locale. Great. The only thing remaining, well, the color scheme already works. The theme uses a slightly different API for loading fonts. So I'm just going to replace this by the family font resource implementation that once again comes from Moco. With that out of the way, the only thing left that we need to remove is this kind of activity file. But luckily, because Compose Multiplatform does a very nice split between what is Android-specific and what is common, we can actually just remove this part entirely. So we're just left with our Rally app. We can go back into the entry point that we initially had. First of all, we make sure we don't have any imports that are not being used. We go back to our app, and we just call Rally app from in here, making sure we import the correct function. Great. So with that out of the way, hopefully we can just go in here, make sure we don't run this on the physical device, because then you can't see it. So instead, we're going to do it on the virtual iPhone, and we'll also see it on the Android device. On the Android device, we're not going to see anything that's going to be particularly interesting because, well, we took the app and we just moved it to a different library. So in the end, it'll behave exactly the same. This is one of the big power-ups of Compose Multiplatform. If you are on Android, just like you're seeing right here, we just saw it switch, it's just Jetpack Compose. It's the real deal. There's nothing different. On iOS, we're just going to give this a little bit of time for the compilation to work. I have a feeling my machine might be. There we go. And we can see the same app running on iOS. And you can see that the little alert dialog that's up there, that's flashing, that one just flashes as well. If I move over here, all the animations, they work exactly the same as you had designed them on Android, so I didn't have to touch any of them. I don't even know how this circle is done. I haven't understood any of the underlying parts. I was just able to move it over, and it still works, which I think is quite exciting. The white bars at the top and the bottom, those are just because we are currently working on providing common insets, and then after you have that, you'll be able to also extend through the full screen and work around Apple's dynamic island magic touch bar. I don't know, whatever they call it. Exactly. OK, great. So that was our little live demo. We saw that for the most part, the APIs really are the same, except for when we are currently delegating to a couple of third-party implementations. We have official templates available, as well as community-maintained ones that add a little bit of extra stuff out of the box for you. And we kind of saw that, at least in this best-case scenario, where we weren't really relying on any of the underlying system features, we were actually able to support iOS for our app in just a couple of minutes, which hopefully lends a little bit of credibility also to the case studies we saw in advance. I think it is still important to note, though, that there is no magic switch to just turn over your app and it's wow, now it works. on iOS. And that's because your app still has to be a Kotlin multi-platform app. It's great on the one hand because it means you get native binaries that run on iOS, but it means that you also need to do a little bit of work, especially if you're depending on any libraries that are JVM only at this time. Of course, we have a couple of different approaches for this. You can use expect and actual to define platform-specific implementations for things, or of course, you can choose a multi-platform alternative for the libraries that you are using. Kotlin multi-platform has been around for a long time, so networking or persistence abstractions have existed for a long time and have been used by a lot of people as well. And even Compose Multiplatform, being less than 90 days old on iOS, already has an ecosystem itself. I want to give you a little bit of an overview so that you can pick out a couple of things that maybe you can get started with when you're experimenting. A couple of them are Compose specific, a couple of them are just multi-platform in general. Before we do that, I just want to give a super quick shout out to Google because they have actually started bringing more and more of their own Jetpack libraries to multi-platform. So collections, data store, and their annotations library are already available as multi-platform artifacts, which means if you depend on those, you don't have to switch them out if you're doing Compose multi-platform. And hopefully, as more and more libraries kind of add this kind of support, it'll become easier and easier for you to move to Compose multi-platform or just multi-platform in general. It's also great fun because it adds this nice little drop-down to some of the Android developers documentation where you can select what functionality is available on iOS. I never thought I'd see that word in the Android developers docs. That's kind of fun. So for navigation, while we don't support Compose navigation out of the box yet, the community has already stepped up, and there's a couple of different approaches that all work with Compose multi-platform. Voyager is one of them. That's kind of a modern reimagining of navigation with screen-based UIs. Pre-Compose is something that's particularly easy if you're already familiar with things like Jetpack lifecycle, view model, and navigation. And then there's also Decompose that provides a business logic components approach. If you want to learn more about another library that's currently entering the Compose multi-platform space, I suggest you go to Zsolt's talk, which is a little bit later today in this very room, who's going to talk about how Apex 2.0 is going to embrace Compose multi-platform as well. We already saw a couple of parts of the Moco suite of libraries, in our case specifically resources, that gave me a little bit of a hiccup, but also made it possible for me to move things much quicker. They have a bunch of different libraries here, whether that's permissions, integration with geospatial data, or the biometry sensors, and they're all available on multiple platforms, and they provide integrations with Compose multi-platform as well. Just like in regular Jetpack Compose and Compose multi-platform, image loading is a topic you typically outsource to a library, and we have a couple of different ones that all have their own flavors and provide caching, asynchronous loading, and so on. As said in the keynote, one of the more popular libraries besides Compose Image Loader and Camel is Coil, the coroutines image loader, which is now actively working on Compose multi-platform support as well, as seen in the keynote. Going a little bit below the layer of just the UI, because I know that if you're doing the kind of migration, these are the things that are going to come up. You need some kind of underpinning libraries as well, right? For networking, typically for multi-platform cases, that is Ktor. If you enjoy having kind of a retrofit style API, then you can use Ktor Fit, which moves over most of the important APIs on a Ktor-based multi-platform backend. We already mentioned Data Store is one of the Google libraries that's available multi-platform now, but if you're looking for a database replacement, for example, SQLite is another multi-platform implementation that has already found quite a community behind it. And of course, all of these can be nicely integrated with other libraries, like, for example, Kotlin X serialization or any other replacements for example, JSON or JSON libraries. Out of the box, Compose multi-platform currently ships with the exact same design artifacts and composables as you see them on Android. That's the exact thing that made it possible for me to just grab the whole material design example and just kind of copy-paste it over, and it still works. If you're looking for design elements beyond Material and Material 3, you can, of course, either build your own elements, customize the material design, or you could build on top of some community design things like, for example, the Compose look and feel. So this one, for example, is built by one of our wonderful community members, Alexi, who's kind of currently working on adaptive widgets that can switch their design based on whatever platform you run them on. This is all still very early days, and I would not expect any of them to be very complete, but it's, I think, a good reminder that all of you are also the community, so if something is important to your heart, a lot of these folks also accept contributions. Honestly, I think that once again, just putting it into perspective, it's been 87 days since we first announced it publicly. The fact that most of the building blocks that you need to build an application are already available is a great trajectory, and I think bodes quite well for Compose Multiplatform. But hopefully, if you are someone who is maybe maintaining libraries or, for example, some kind of widget catalogs with composables, we would also ask you to see if maybe you can make them multi-platform and even publish your composables as Compose Multiplatform. Because it's very important to note that Compose Multiplatform artifacts are actually backwards compatible. That means if you are publishing your artifacts or your fancy button that does a cool animation or a wiggle, and a regular Android developer that doesn't do multi-platform development wants to use that from their Jetpack Compose application, they can. It makes no difference. There's no difference in developer experience. It all works exactly the same. So really, if you are publishing with Compose Multiplatform, you're not really putting any drawbacks on your users. You essentially just allow more people to use the things that you've already built. It's actually quite exciting because this kind of backwards compatibility is also enabled by the fact that we cooperate with Google on this behind the scenes and make sure that Compose Multiplatform and Jetpack Compose stay in sync. This kind of backwards compatibility also adds one more superpower to Compose Multiplatform, which is what I would call graceful decomposition. Because it's really important to note that if you take Compose Multiplatform on Android, it is just Jetpack Compose, which means if you ever want to remove Compose Multiplatform for iOS from your mobile project, then the thing you're left with is just an Android app. Your efforts weren't wasted. So yeah, if you have any kind of reason and you're saying you want to build native UIs for different platforms, you don't have to throw anything away. And because you've already architected your application in a multi-platform manner anyway for Kotlin multi-platform, you can even continue sharing those parts that you want, whether that's your data and networking stack or all the way up to your business logic or even your view models. Together with the kind of, the code reuse that we've already seen, the fact that you obviously can reuse your knowledge as well that you already have with all the Compose APIs are some, and together with this kind of graceful decomposition, I'd honestly say those are some of the superpowers that we have with Compose Multiplatform. Great. So at this point, of course, I would love to throw the ball over to you. If you are an app developer, we'd love to see you experiment with Compose Multiplatform for iOS, for Android, and if it fits your use case, beyond that as well. If you are a composable or a library developer, we'd love for you to see what it takes for you to support Compose Multiplatform, because there's more and more folks that are adapting it. And I think it would all be great if the ecosystem would continue growing on such a great trajectory as we already have. But yeah, maybe don't use it for production apps just yet. We have a couple of official sample apps that you can explore. We already saw the image viewer apps and briefly took a look at the chat app. We also have a couple of other ones that show different architectures and integrate with different third-party libraries. The community has also stepped up already and has built a bunch of different applications, whether those are samples, demos, or just personal side projects. And you can explore all of those on GitHub as well and learn more about Compose Multiplatform as a technology. The way that you get started with all of this is you go to jb.gg/compose and hopefully find your way from there. We also want to invite you to, of course, join the Compose for iOS channel on the Kotlin Lang Slack. And we would love to hear any kind of feedback you have, because we really want to make sure that we give you the best experience as a developer possible, and we really want to make sure we do things based on your feedback. We're also currently working on making our docs even more accessible, and we, of course, want to do this informed on your requests as well. What are the most burning parts? So yeah, honestly, Compose skills are probably more valuable nowadays than ever before, and I think Compose Multiplatform certainly adds on top of that. All the time you're investing in Jetpack Compose is going to make you an awesome developer in many more ways. So yeah, thank you so much for joining today.